Hello everyone, we're back again for another week of stats here. Getting some stuff down. We're going to move on to chapter 22, which we did look at one point when we learned about the student T distribution, and we're going to be using that chart in this problem. So I did upload the formula sheet onto the Google Classroom. I'm going to also be trying to get some practice problems from the AP exam for you guys to do. I just have to get you the link. And so it's going to be one of those situations where we're going to have some problems from class, and then there's also going to be some practice problems that I'd like you to do during the week as our work. The Google Classroom, I will be putting up an assignment at 10 a.m. today for you guys to do just some work on the student T distribution chart. So you'll have to have that out, you'll look things up, fill in the blanks. I just want to make sure everybody can still use the chart. I'll have a couple of problems on a worksheet like this for you guys to do and get back to me, and then there'll be some practice AP problems for you guys to do as well. I certainly encourage you to do whatever work you can. We'll ask questions. I will schedule a Zoom meeting time. Some people ask it to go a little bit later than it was this past week, so we'll see what we can do. I'll put that on the Google Classroom to let you know. So this problem here, this is the second problem on what I called the note sheet. The first one I did out. Second one is about insurance companies that are looking at people's life expectancies. And so I have the important information up here. We're going to be trying to do a one sample t-test for this problem. We have to do hypotheses based on the information that we're given. We're given that the mean life expectancy was 77 years. We're interested to know if it has increased, so we're going to do a greater than problem for our alternate hypotheses. The alpha level will be 5%. The sample mean and the sample standard deviation, that's going to come from the calculator. You'll have the list 1 filled with the numbers from the chart, and then do one variable stats to get the mean and standard deviation, all those values. So that's where all that comes from. Sample size was 20, which means our degrees of freedom is going to be 19, and that's going to be which row we use on the chart. Okay, so to check conditions, it was randomly selected policies from the problem. 20 is less than 10% of all their policies. We have to assume that this is a insurance company with thousands of customers. And then the third condition is something new. We're not using NP and NQ. We're not really using the sliding scale anymore. It is sort of based on that. But many of these problems, what they'll do, are the problems where they actually give you all of the values. What we have to do is actually create a histogram on our calculators from the data. And the idea is that for the most part, the shape that the sample is should at least be reasonably the same as the whole population. So as long as there aren't outliers and skew and like a terrible distribution here, it passes the test. It doesn't have to be normal. It just has to not be terribly skewed to one side. So that's what we're looking at here. So the graph that I had gotten looked like this. So I'll draw this on here. And even though this isn't going to be symmetrical, that's not the level that we need to be at. We don't have to be perfectly normal. We just need to have something that isn't terrible. Okay, so I'm going to call this symmetric. And no skew or outliers, and that's going to be why it passes the conditions test. So we're going to do a one sample t-test here. And in setting that up, our formula for the t-score is going to be, we're going to have our sample mean minus what we expected from the hypothesis. And then here we're going to have our standard deviation divided by the square root of n. Now that standard deviation is based on our sample, not the population, because that's the best information that we have. Okay, so in this case, we're going to go 78.6 minus 77, and the standard deviation 4.47 divided by the square root of 20. Okay, degrees of freedom was 19. Here we're using the full sample size, so we're going to go by 20 there. So we get 1.6 divided by 0.99. All right, this divided out to almost exactly 1. And that comes out to 1.61 for our t-score, not z-score, t-score. And we would look that up in the chart. We would go across row 19 until where we found 1.61, where that would fill in. And we get probability t with 19 degrees of freedom is between 0.10 and 0.05. Okay, so notation wise, we get the subscript here telling us which t distribution that we used. All right, comes out between 10% and 5%, which actually tells me something very important, which is it's greater than 5%. Okay, it doesn't matter exactly what it is. If you do it on your calculator, I believe it comes out to about 6.1% as you do this. So in looking at all of this work, we get our conclusion here from the fact that this was definitely greater than 5%. And that's what we'll write. So since the p-value was greater than 0.05, we fail to reject okay, so still the same rules as all of the other ones. Greater than 5%, fail to reject. There was not significant evidence to convince us that there was not significant evidence to convince us that the average age was greater than 77. Okay, so that's what we're going with there. We failed to reject the null hypothesis, and we would not change the policies.